For this week's experiment, we are going to be looking at penny oxidation, and more importantly, looking at how a mixture of salt and vinegar reverses this effect of the oxidation on a penny. So for this experiment, you're going to need an empty bowl, a bowl with water, vinegar, salt, a mixing utensil, and then I tried to find as many dirty pennies as I could. So these ones, as you can see, are really dirty, as well as this one. And then I have a semi-dirty one, and then I have some newer pennies as well that have not had that much time to oxidize. All right, so first I'm going to go ahead and pour my vinegar into my bowl, and then I'm going to put some salt in there as well, and use my spoon and stir that around so it starts to mix together. So when you combine the salt and vinegar, they form a very small product of hydrochloric acid, but it also produces sodium acetate and hydrogen chloride. So the acetate is from the vinegar, and then the sodium chloride is table salt. So I'm gonna let this mixture kind of settle a little bit and dissolve a little bit more before I go ahead and do this experiment. I think it's important to understand what causes a penny to oxidize this way and turn, almost looks rusty, but it's not rust because there's no iron in a penny. A penny is made up of copper, and so it has copper atoms in it. However, though, when a penny or the copper is combined with oxygen atoms from the air, it makes a molecule called copper oxide. So that's what that dull and dirty look is the copper oxide. And so that's why older pennies are actually look dirtier, because they've had more exposure to the air versus our newer pennies have. So this penny is from 2018, and this really dirty one is, if I can even see it, is from, I think it says 1960. So this is made up of more copper than the 2018 one is, so that's why it's gonna oxidize better than the newer one, because there's less copper in the newer one than there is in the old one. All right, so now we are going to, now that the salt looks all the way dissolved, I'm gonna put a dirty, really dirty one in, a semi-dirty one, and we'll put a newer one in just to get the extra shine, and then I'm gonna also put in another dirty, and we're gonna let that sit. And if you can already kind of see that the dirty and the dirty one is already starting to get a little bit cleaner, just from the time we put it in there. So why does this happen? So, like I said, the hydrochloric acid that forms when the vinegar and salt combine works with the copper oxide and actually starts dissolving some of that copper in the water. So the salt and vinegar dissolves a chemical that makes up the copper surface of the penny, so it makes it look shiny. And we can already see that the dirty penny is already looking way cleaner than it was. So what happens though is that when the copper atoms leave the penny, they also leave some of their electrons behind, and then rather having whole copper atoms in liquid, you've got copper ions. And then, so they're basically copper atoms that are missing 2 electrons. And these ions in this mixture are positively charged. So the chemical reaction that occurs in this mixture is called the oxidation reduction. So because the pennies are giving up oxygen, you're removing the oxygen that caused it to oxidize in the over time from the air. So what happens is the dirty penny started off looking like kind of like this, and if we take it out and we put it in the water, it stops a reaction. So then it's starting to, actually you can kind of see the face a little bit more, and the back of it is definitely a little bit cleaner. But what also, I tried out this experiment before I filmed it, and I left out some pennies without putting them in water, so I let them air dry, and kind of hard to see, but right here is a line of green and like a greenish blue. And what happens is when you remove the penny from the vinegar and salt, it will join with the air, oxygen from the air, and the chlorine that got broken up in the salt from the sodium chloride. Now that sodium will combine with the air to make a bluish green shine or residue on the penny. And a great example of this is the Statue of Liberty. When we got it, it was actually copper color, so this color, and because it's been exposed so many years over the time to air and oxygen, it's caused that greenish blue compound malachite to form on top of that copper, and now that's why it's that greenish color. And then as you can see, the dirty penny is, the second dirty penny I left it in longer, and it's definitely more legible than the first time. And that is what happens to pennies when they are oxidized.